Then 1.4, solving linear equations with variables on both sides. That last section did not have x's on both sides. So what do we do? No problem. We can work with that. Remember, solutions are our answers to the equation. All right, here's the principles of equality again. Remember that when you're looking to use addition or subtraction, it's usually to make zeros. Multiplication or division is to make ones. Now, we're looking at multi-step equations, which means sometimes we'll need more than just two. Okay, for two-step equations, we need two. For one-step equations, we usually need one. But for multi-step equations, usually it is still limited to three, okay? Because when you have multi-step equations, sometimes the steps include distribution and also combining like terms. So if you can get those two down, then you should be in good shape. All right, so this one we see starting out has x's on both sides. So look, I only want x's on one side, right? Like in the end, what I would really like here is just x equals something. I don't care what it is, it just needs to equal something. Well, okay, so see how I got my x on the left? I'll just keep them on the left. That means the x is on the right, I want to zero out. So I can use principles of equality to do that. Can you, for reals? You can, yeah, do it, right? I'm going to make that a zero. How am I going to do it? It's negative 11x, add 11x. But if you do it to one side, you got to do the other side. See how those are that's just a like term on both sides there. Well, negative 11x's plus 11x's, I can put the zero there, but I'm actually going to need it right here. And so I got 17x's plus 11x's, that's going to be 28x's. And then divide both sides by the coefficient, 28. 0 divided by 28, that's 0. Is that true? Will that be a true statement? Will that make it a true statement? 17 times 0 is 0. Does that equal 11, negative 11 times 0? Yeah, that's 0. 0 equals 0, that's true, and that's okay. So there it is. All right, so here's a problem, and once again, we're dealing with x's, okay? Like we got negative 18. It's not like there's any other numbers here on the left side. And remember, our objective here is to isolate the x's. So what that means is I don't want x's on both sides of the equal sign. I only want them on one side. And I know I said this before, but generally speaking, students prefer to have the x's on just one side of the equal sign. I'm sorry, I mean the left side of the equal sign. So that means that this x right here, it's misplaced, meaning, and I'll set up my principle of equality here, right? Whatever I do to one side, I got to do to the other side. But I need to zero out this x. Now, just so we remember, that's a phantom 1x. The coefficient of x there is 1. So in order to zero it out, I'm going to have to subtract it from itself. So minus 1x. It's just if I do it to one side, I must do it to the other side as well. Now, we'll still have the equal sign there, but moving from left to right, 4x's minus 1x's, that'd give us 3x's. Then the 1x minus 1x, that zeroes out just like we wanted. And then this 18 right here, I'm going to say it's negative because of the minus operation to its left, so it becomes, or it remains negative 18. Now I have 3x's, and that was one step right there. Two can still be multi, but I don't want this to be 3x's. I'd rather it be a phantom 1x, right? So I'm going to divide both sides by the coefficient 3. That's because if I do it to one side, I got to do the other side, and then 3 divided by 3 there is 1. So there's 1x, or you can make it phantom 1x if you'd like. But this then equals negative 18 divided by 3 is negative 6. So that ends up being our answer. We can check, right? Negative 6 minus 18, that would give us, on the right side there, that'd give us negative 24. I forgot we had the x on the left, but 4 times negative 6, that also would be negative 24. And we know that negative 24 does equal negative 24. That's true, which means that negative 6, x equals negative 6. If we replace x with negative 6, that is the solution. That is what makes this equation true. All right, how about a problem like this one? Now we got x's on both sides of the equal sign, and we also have numbers on both sides of the equal sign. If we need to write our answer as a fraction, we will. But once again, and I'm going to show it a little bit different this time, but I'm going to put x's here and then numbers here. And then again, that's not a hashtag symbol for those of you that are younger. That's a number symbol for my generation. So I want my x's on the left. I want all my numbers on the right. That means that this positive 8 right here, that's misplaced. I don't want it there. I got to zero it out. So I'm going to subtract 8 not only here, but if I do it to one side, I got to do the other side right there as well. So I'm subtracting 8 from both sides. I'll drop this 7x because it's on the correct side, right? It has an x, so it's on the correct side. But 8 minus 8 there, that's going to be 0. So this one then equal, I'll drop this negative 7x. And then I have 7 minus 8, which would be negative 1. But now continuing to look at this, right? So that was one principle of equality. But look, now I got some x's on the right side of the equal sign, but I only want numbers here. So I need to zero out that negative 7x. So I'll have to add 7x there. Just, if I do it to one side, I must do it to the other side as well. So I'm going to add 7x to the left. So on the left, 7x's plus 7x's, that'd be 14x's. This will equal negative 7x plus 7x's, that'd be 0x's, or nothing left. And then I'm going to drop this negative 1. Well, you can see everything's placed accordingly. We have x's on the left, numbers on the right. So the last thing we got to do to solve this is divide both sides by the coefficient. That's 14. And then we end up with x equals negative 1/14. Okay, and it's a fraction, that's okay. Remember, it's okay to have fractional answers. And I don't know what this is, but if you plug the x into the calculator, you'd get a true statement right there. That's going to be like negative 1/2 plus 8, so 7.5. So over here, you'd probably get 7.5 there too, it looks like. Yep, you would. That's right, negative 7 times negative 1/14. That's positive 1/2 plus 7, 7.5. Boom. All right, here's another problem, but you'll notice now, not only do we have x's and numbers on one side, but also on the other side. And we're just going to focus on one side at a time. There's like terms that we can combine. So, and yeah, we'll make the answer a fraction if we need to. But what this means right now is I'm pretty much ignoring that right side of the equal sign. I'm completely ignoring it, okay? And this goes back to the idea of just kind of focusing on one part at a time of problems, you know, simplifying them or breaking them down into smaller, more manageable parts. So right now I'm just looking at one side of the equal sign. Well, I'll get rid of this later, but I don't want to even look at this stuff. And I got negative 4x's minus 7x's right there. Those are like terms. So I can combine these, right? So this is how many x's? Negative 4x's minus 7x's. That'd give us negative 11x's. But then I have these other like terms to combine, the negative 1 and negative 3. Negative 1 minus 3, that's going to be negative 4. Okay, so that's as much as I can simplify. I got an x term and a constant term, number term. Nothing else I can combine here. So I would be looking then to go now to the right side of the equation. So I'll move this. In fact, kind of covers up that. So at this point, I'm looking at the right side, and I want to combine any like terms. I have negative 9x's, and again, that's a positive 1x's. That would give us negative 8x's. And then the negative 6. It just stays negative 6 there. Okay, so I've completely simplified this equation right here. So this is what I'm left with, right? Negative 11x minus 4 equals negative 8x minus 6. And we're looking at a problem that's very similar to the one that we just barely did. I want to put all my x's on one side and all my numbers on the right side. Now on the other side, I should say. On the last problem, though, I put all the x's on the left and the numbers on the right. This time I'm going to show you that it doesn't matter which side you put the x's on, okay? It does not matter which side you put the x's on, which means I'm shooting to have all my x's on the right and then all my numbers on the left. Now, the way that I have this set up, and again, you can keep it always the x's on the left, numbers on the right. Most students prefer to do that, but I'm showing you that it doesn't matter, right? This negative 11x is on the number side of the equal sign. So that means that I'm going to have to zero it out. Okay, so a negative 11x, I'll have to add 11x's to make that 0. Just if I do it to one side, I must do it to the other side as well. So working through this, negative 11x's minus, or plus 11x's, that becomes 0, just like we thought it would. Then I'll drop my negative 4 here. This is now equal to negative 8x's plus 11x's. That's going to give me 3x's right there. And then the negative 6, once again, it just gets dropped. Nothing, we didn't operate with it, right? Now, scanning this problem, I have a number on the left side, that's good. I got 3x's here on the right side, and now I got negative 6. This is in relation to the equal sign. Negative 6, though, it does not have an x term. So I got to zero it out as well by adding 6 to both sides. Okay? And once again, we look at this term as negative 6, right? Because it takes the operation to its left as its sign. That's negative 6. Negative 6 plus 6 there, that's going to give us 0, just like we want. But now on the left, which is just where the numbers are, negative 4 plus 6, yeah, that's going to be 2. And that's going to equal that 3x, which I just need to drop it. Okay, so 2 equals 3x. I'm down to my final principle of equality. I've used the addition principle of equality twice. Now I will have to divide both sides by the coefficient 3. And this gives me pretty much my final answer there because the coefficient now is a phantom 1, but I get 2/3 out of that.
Jordan Sharp, please come to the front office. Jordan Sharp to the front office, please.
So if you go back and replace all the x's with 2/3 in the original statement and then just plug that into a calculator, you'll find that 2/3 is the answer, so I boxed it in. That would give you a true statement there from the beginning. Now I'm going to point this out with this problem. Okay, so I'm kind of backtracking here. Is you notice at the beginning when I added 11x's to zero this out, I put this plus 11x's below the other x's. I did not put it below the constant term or the non-x term. That's on purpose, by the way. Okay, because if I add 11x's to -6, they're not even like terms to combine. So I have to combine it with the other x term, which in this case is the -8. So you want to keep that in mind. Even like down here with the -6 when I added 6, I put it below the -4. Well, there's no x terms. Yeah, but I line them up so that I know that I'm operating with like terms. Okay, so I'll try to do this one pretty fast. So there's some distribution. It's a little bit bigger though, right? So I got 8x's, 8 times -4, that's -32. And then I got another distribution. That's okay. That's -6 times x, which is -6x. And then -6 times +6 would be -36. Everything else stays the same, so we still got -6x, and then also the -4. So I did distribution, just like the order of operations says you should do multiplication first. Now I'm going to combine into like terms with addition or subtraction. So I got 8x's and -6x's right there. That'd be 2x's. There's nothing to combine with the -32, so it stays. And then that's the left side. On the right side, I got the -6x's. I'll just drop that, -6x. But I can combine my -36 and -4 to be -40. Now again, you got choices right here. Do you want the x's on the right? Do you want them on the left? It doesn't really matter. For the most part, students like to put them on the left, which means you usually want x equals something. But you don't have to. You can put them on the right. Now, because I have x's on the right and the left, I'm going to have to zero out one of them. I'm going to choose the -6x's. So I'm going to zero it out by adding 6x to both sides. Okay, so that's 2x's plus 6x's. That's 8x's. Some of you would do this in one step, but we don't have time to show that right now. Maybe that's all the time we have. But that's 0. And then I got -40, which I need to drop. I now have that -32, but I want to zero it out because I don't want anything added or subtracted. My 8x's right there. So add 32 to both sides. Oh, that's going to be nice. That zeroes out. The 8x drops, which now equals -8 after the addition. Then divide both sides by 8. And give yourself more space. And x equals -1. Now, when solving equations, it's possible you may prefer to use what I call the switch and stay game. But remember, this is a solid process for any equation. I mean, the switch and stay game is. It's just a little bit different, right? First thing you should always do is distribute. And sometimes you won't see any need for distribution like we've seen in some of these problems, but sometimes you will. Always distribute first if you need to. Then you will combine like terms if you can. And again, that's only on one side and then the other side. Then you use principles of equality to isolate the variable from the numbers, combining like terms along the way, and then finally you divide by the coefficient. I should have added a fifth step here, which you should always do, but that's just a check. Right? Remember, you can go in and check to make sure that whatever value you have is the actual solution to the equation that you had started with. So here's an example. I'm going to show you how to use the switch and stay game. You can see right there, first thing we're going to do is distribute, right? So I put those above so I have a little bit of space to work, right? In any case, first thing I must do is distribute. Is there any need for distribution? Yes, there is, because we got 3 sets of parentheses. We got values on the outside that need to be distributed. And remember, distribute also means multiplication, right? So what am I distributing? Well, I'm gonna move from left to right, and the first set of parentheses I notice is this 3x plus 1. What number am I distributing though? Because it's not even showing a number. Be careful not to distribute 5x, because remember, distribution is multiplication and it's separated with subtraction, so you can't distribute this 5x. So what value is being distributed? It's a -1. So that would be a -1 group of 3x. That'd be -3x's, and then also -1 group of 1, which is just -1. Okay, so that is all of that distribution. let's go to the next set of parentheses, which is 1 plus x. Here I can see clearly that I'm distributing 4. Remember, distribution is multiplication, so I would start with 4 times 1, which is 4. And then 4 times x, or 4 groups of x's, would be positive 4 x's. Now the next set of parentheses, I've got this set of parentheses here, and I'll show this as negative 1x minus 2, just so I know what I'm multiplying by. I am distributing here, though, a negative 3, not just 3, a negative 3. So that's negative 3 times negative 1, which is 3x's. Sorry, negative 3 times negative 1x's. And then negative 3 times negative 2, which is positive 6. So once again, the positive is shown with addition right there. Next, I'll distribute 2 into 3x's. That's 2 groups of 3x's. That's positive 6x's. And then I'll distribute 2 into negative 5, which is negative 10. 2 times negative 5 is negative 10. So that's from the distribution, right? But we still need to consider the rest of the expression, or the equation here. So I still have that 4 plus 5x minus 3x minus 1. And then I still got the plus 12x equals 4 plus 4x, and then that was a positive 3x right there, so there's a plus sign. Plus 6 plus 6x minus 10. So that's all the distribution we have. So we checked off distribution. Boom. Next up, well, in this case, we're not going to actually combine like terms. You could, right? And whether you use this method or the traditional method, you're going to have to distribute one way or the other. But now I'm going to do this a little bit different, right? So next step is to draw a line through the equal sign. Here's what this means. I'm going to take my equal sign and, not too complicated, just draw a line through it like this. In fact, I'll make it a little bit longer. I'm making that longer because we got a lot of terms, and we're going to have to deal with this, okay? So, did I draw a line through the equal sign? Yes, I did, so check mark. Choose which side of the equal sign you want the x's on, left or right. I choose left because most students prefer left. That means the numbers will go on the right. Okay, so I did that. I checked. Next up, play from left to right, the switch and stay game. From left to right, play the switch and stay game. Okay, so switch and stay game, one thing you'll need to know is if a term crosses the line, then you change that sign, okay? And that's how you're gonna play the switch and stay game right here. So, now that we have that, let's start over here on the left with my first term, which is a negative 4. Now it's not an x term, it's on the wrong side, so it has to switch. So the negative 4 is going to switch into a positive 4. Boom, and I used it up, I cross it out. My next term is 5x. It has an x, so it's going to stay 5x, stays positive 5x. We used it up. The next term, again, this is negative 3x, so it will stay negative 3x because it's on the right side. It's on the left side of the equal sign, or the line. So we cross that out, we used it. Next up, negative 1. It does not have an x, it's a number, so it has to cross the line, change the sign. It's positive 1. Cross it out. Next up, positive 12x, it's positive, so I show it as plus 12x right there. And I do need to show the signs, by the way. That'll be important later. But it stays positive 12x because it's on the correct side. Next up, we have this 4, and it's on the correct side, so it will stay positive 4. Next up, this is a positive 4x, but it's on the wrong side, so it has to switch into negative 4x. Notice I'm crossing these out as I go too. The next term is this positive 3x, but it will cross the line, so I will change that sign into a negative 3x. Cross it out. Now my positive 6, it will stay positive 6 because it's on the right side of the equal sign. And then this positive 6x will switch into a negative 6x. And then finally, our last term, negative 10, will stay negative 10. Okay, so this what this does now, because you can see here at the top, it now says to add and subtract. But I did finish the actual switch and stay game. So I'm moving on now to adding and subtracting. And all this means is that we're going to go through all these like terms, which we've now lined up, and just add them together. So on the left, I've got all my x's. How many x's do I got? Well, I got 5 x's minus 3 x's is 2 x's plus 12 x's, 14 x's, minus 4 x's, 10 x's, minus 3 x's is 7 x's, minus 6x's. Oh, hey, what do you know? That's 1x's right there. Now I'm going to keep that there, but let's look at the right side and then add these values together. So I got 4 plus 1, that's 5. Plus 4 is 9. Plus 6 is 15. Minus 10 is 5. Now, usually what we would say at this point is, because I just did all the addition and subtraction, but the last thing I would do is say, divide by the coefficient specifically to solve. And in this case, you could say, well, you're going to divide both sides by 1. In any case, it's still going to be x equals 5, because anything divided by 1 is itself. But you divide by the coefficient no matter what it is. It could be a fraction, it could be a decimal, it could be negative or a whole number. In any case, x equals 5. This is actually our final answer right here. And you could check, even in the original problem, and you can use parentheses in your calculator to check, just replace all the x's with 5. But you would find that this would be a true statement right here if you replaced all the x's with 5. But that's done. Now, did you have to do that? No. Like I said, you could have distributed and then combined the like terms here with the x's and numbers, and then these x's and the numbers, and then use your principles of equality to solve it. I'm not saying that you have to use the switch and stay game, but for some of you, maybe that organizes it a little bit better for you. And so if you like it, go ahead and use it.